Alright, here we go, video 4 from Unit 5. This is now the sum and differences using sine. We'll have a different formula here, and but the procedure that we're going to follow will be nearly the same. But it is important that you recognize how different the formulas are that we're going to be using. Alright, so on the top of your Unit 5 video 4 note sheet, go ahead and write down our two formulas for the sine using sums and differences. So the first one I have here is the sine of angle A minus angle B equals the sine of angle A cosine of angle B minus the sine of angle B and the cosine of angle A. So I kept the order of the functions sine, cosine, and even the subtraction sign stayed the same, but my angles were opposite. So I used sine of A here, but sine of B on this side, cosine of B here, and cosine of angle A on that side. And then I have the sine of angle A plus B, which will stay the same except it'll be a plus sign in the center here. So I have sine of angle A cosine of angle B and sine of angle B cosine of angle A. So those are two. Again, you'll have to know these for our upcoming quiz and test. Alright, so let's get started then. So I have the sine of 0 degrees minus theta. And I'm going to start by writing out my formula to be the sine of angle A cosine of angle B. This is subtraction. Then I have the sine of angle B and the cosine of angle A. Well, angle A in this is represented by 0 degrees, which we know to be 1, 0. And theta doesn't have a point because it could be anywhere. And with that, I'm just going to use theta. So the sine of angle A is the sine of 0 degrees, the cosine of theta, minus the sine of 0 degrees and the cosine, the sine of theta and the cosine of 0 degrees. And I can start replacing those. So the sine of 0 degrees is 0, and the cosine of theta is still the cosine of theta, minus the sine of theta, and the cosine of 0 is 1. So with a 0 canceling out here, we end up with negative sine of theta. Alright, for the second one, I'm doing number 4, so make sure you move to number 4 on your worksheet, and you can try 2 and 3 later. The sine of 90 plus theta degrees. And for this one, again, I'm going to start by writing it out. So I have the sine of A, the cosine of B, plus the sine of B and the cosine of A. 90 degrees is located at 0, 1. So if I start replacing this, then I have this, and A is 90 degrees and B is theta, then the sine of A is 1, the cosine of, this is the cosine of theta, plus sine of theta, and the cosine of A, and A in this case, the cosine is 0, which makes this part cancel out and it simplified down to just the cosine of theta. Alright, let's try number 5, where we actually have two different angle measures involved. So I need to know that this is angle A and this is angle B, and 90 degrees, again, has the location of 0, 1, and 60 degrees, without drawing a triangle, will give me 1/2, root 3 over 2. So that is my cosine and my sine. So to write this out, I will have the sine of A, cosine of B, using subtraction, sine of B, cosine of A. And now I can start substituting my numbers in. So if I want to write it out using A and B and replacing them, it might help you. So I'm going to take that extra step here. So this is the sine of 90 and the cosine of 60 minus the sine of 60 and the cosine of 90. And I can start now replacing. So the sine of 90 is 1, the cosine of 60 is 1/2. Minus the sine of 60 is root 3 over 2, and the cosine of 90 is 0. So in this case, this part cancels out and my answer is 1/2. I can check this because I know that 90 minus 60 is 30 degrees. So if I were to verify with 30 degrees, I would end up here, the sine of 30 is 1/2. Now that's a way to check it. You still have to show the work, and you went through the process of using the sum and differences of sine. Alright, You can finish up numbers 2, 3, and 6 on your own. And numbers 7 and 8, we're moving down to the bottom of the page there. Just as we did with our cosine, we're going to have to draw the triangles for these. So I'm going to start by drawing them, and it says that both S and T are in quadrant 1, so I'm going to draw my two pictures where both S and T fall into quadrant 1, labeling them with a different color just because it's easier for you to see what I'm referencing. So the cosine of angle S based on this is that there's a 3 and a 5. And then I need to find the missing side. This one turns out to be a nice Pythagorean triple, so that makes this value 4, and because it's in the positive direction, it's a positive 4. So I end up with finding the sine of S to be 4 over 5. Then I have the angle T also located in the first quadrant, where it tells me that the sine is 5 over 13. This too is a Pythagorean triple. If you need to use the Pythagorean theorem to verify it, you can. But I end up here with this side being a 12, which means that my cosine of angle T is 12 over 13. Now that I have all of those values, I'm able to go ahead and start finding the sine of S plus T and the sine of S minus T. So I'll start with the sine of S plus T. My sine of S plus T is going to be written as the sine of S cosine of T plus the sine of T and the cosine of S. And I can fill in my blanks. The sine of S we found to be 4/5. The cosine of T is 12/13 plus the sine of T they gave us to be 5/13, and the cosine of S they gave us to be 3/5. If I go ahead and multiply my numerators and my denominators here, I will end up with 48 over 65 plus, in this case I'll get 15 over 65, and when I add those values together I get 63/65, and that is the answer for the sine of S plus the sine or plus T. Because my formulas don't vary much except for the sign in the center here, the SIGN, if I want to find the sine of S minus T for this particular problem, I would end up with 48 over 65 minus 15 over 65, which is 33 over 65. So that would be the difference of those angles. Let's try this again on the next picture, or the next problem. So I'm going to, this case, because they're both located here in quadrant 2, then I'm going to draw my two pictures where both angles are located, in quadrant 2. And this is angle S, and then we'll have angle T on this side. So that makes the cosine of S, it says that it's -1 over 5, and I'll have to use the Pythagorean theorem to find out my missing side because this is not a triangle triple. So that's -1 squared plus y squared equals 25, that's the 5 squared. So it'll be y squared equals 24, and when I take the square root of that, I get both positive and negative 2√6. But because I'm going into the second quadrant and I want my vertical side to be positive, I'm using positive 2√6. This is similar to one of the problems we did in the cosine video. Which means that I'm going to have here that my sine of angle S is 2√6 over 5. Alright, for this triangle here, I've got the sine to be 3/5, which makes this another Pythagorean triple, but it's a -4. Because it went in the negative x direction, making my cosine of S, or T, excuse me, to be -4 over 5. So I'm ready to start substituting my numbers in. So I want to find the sine of S plus T. So I'm going to write it out, the sine of S, the cosine of T, plus the sine of T, the cosine of S. And I can start substituting those values in. The sine of S we calculated to be 2√6 over 5, and the cosine of T to be something we found to be -4/5. The sine of T they gave us to be 3/5, And the cosine of s they gave us to be -1/5. So if I go ahead and I multiply those values, I will end up here with -8 square root of 6 over 25. And this one will be negative or minus 3 over 25. You may put those together and write them with a common denominator, -8 root 6 minus 3 all over 25. Both of those answers would be acceptable. The difference here, if I were to have a subtraction when I found the sine of s minus t, would only change the second part. It would change this to subtraction, which would make a negative times a negative a positive, and my answer would be -8 root 6 plus 3 all over 25. All right, please try numbers 2, 3, 6, and 9 before you come to class tomorrow, and bring this worksheet with you.